You should and you can secure your virtual network at several different levels. The most broadly scoped level of security is at the route table level. Having a private subnet with no direct path to the Internet is one of the best ways to protect your internal computing resources against unauthorized access. The second level is the network ACLs. Provide the ability to define default security behavior for your subnets. The VPC or the subnet layer security is controlled by the network security team. You can use security groups to control behavior at the instance or the ENI level, which is the third level. At the fourth level, you can use a third-party host-based detection software that monitors individual EC2 instances for specific threats, such as malware intrusion, known operating system vulnerabilities, and security auditing. According to AWS, you can use a network address translation, or NAT instance, in a public subnet in your VPC to enable instances in the private subnet to initiate outbound traffic to the Internet or other AWS services, but prevent the instances from receiving inbound traffic initiated by someone on the Internet. The diagram on the slide represents the basic mechanics of how a NAT operates. The network diagram has been simplified for the sake of discussion. Regions, availability zones, routers, and gateways are not shown here. In this example, a database server in a private subnet raises a request for a public Internet resource. Because of the routing table rules defined for the private subnet, AWS routes this non-local request to the NAT server via the NAT's private IP. The NAT server performs the function of rewriting the request. So, to the external resource, it appears that the NAT is requesting this resource via its public IP of 154.10.1.3. When the external resource responds, the NAT reverses the process, changes the packets originally addressed to the NAT's public IP address, and readdresses them to the private IP address of the database server. This way, numerous private instances with only a private IP address can make public requests to the Internet via the NAT instance. Keep in mind, the source and destination checking must be disabled on the NAT. While configuring route tables for NAT, you have to keep in mind a few points. You can create route tables and associate them each with a subnet. Public subnets route non-local traffic through the Internet gateway. Private subnets route non-local traffic through the NAT instance or NAT gateway. A common scenario that you might face with NATs is port forwarding. You have learned how to use NAT to provide access for the private subnet to the Internet. But what if you wanted to open up a specific resource in the private subnet and make it available from the Internet? For example, assume that you have an internal defect tracking database running as a web server on port 80 on a machine in your private subnet. You want to expose this resource to the Internet via your NAT so that select customers and partners have visibility into your development process. To enable this scenario using a NAT instance, you have to log in to the instance and configure it to forward all requests to port 80 of your NAT. The traffic will be forwarded onto an Amazon EC2 instance in your private subnet. However, the NAT gateway does not support port forwarding yet. So if this feature is required in your infrastructure, you need to set up a NAT instance. You can use a NAT instance in a public subnet in your VPC to enable instances in the private subnet to initiate outbound traffic to the Internet or other AWS services. But you can prevent the instances from receiving inbound traffic initiated by someone on the Internet. This slide illustrates the communication between the instances running in the private subnet and the Internet through the NAT instance. The main route table sends the traffic from the instances in the private subnet to the NAT instance in the public subnet. The NAT instance sends the traffic to the Internet gateway for the VPC. The traffic is attributed to the elastic IP address of the NAT instance. The NAT instance specifies a high port number for the response. If a response comes back, the NAT instance sends it to an instance in the private subnet based on the port number for the response. To configure an Amazon EC2 instance as a NAT, you must enable IP masquerading on the instance. It can be done manually, or you can search for an AWS Community AMI image that is pre-configured to serve as a NAT. Ensure that you choose an image with the correct virtualization type for the instance family you are using. For example, you cannot use a PV image for your NAT if you plan to deploy the NAT as a T2 instance. Ensure that the source and destination checking is disabled on the NAT. Source and destination checking is a feature on Amazon EC2 instances that informs the instance to drop network packets that are not specifically addressed to the instance. As the job of a NAT instance is to serve as a proxy for the network traffic of other instances, this feature must be disabled on your NAT. Keep in mind that a single NAT instance can become the single point of failure. So if you are using a NAT instance and high availability is important for your setup, then consider implementing a 2 availability zone NAT instance design as a high availability failover solution. It will prove more effective when used together with auto-scaling. For web access, you can also use Squid proxy architecture. The most modern and recommended way to enable instances in a private subnet to connect to the Internet or other AWS services, but prevent the Internet from initiating a connection with those instances, is to use a network address translation or NAT gateway. A NAT gateway is a highly available and automatically scalable service managed by AWS. However, a NAT gateway is not a free service. A NAT gateway is charged for hourly usage and data processing. In addition, Amazon EC2 charges for data transfer also apply. A NAT gateway is redundant inside the availability zone, but not in the whole region. In the event that the availability zone of the NAT gateway is down, resources in the other availability zones will lose Internet access. To create an availability zone independent architecture, you can create a NAT gateway in each availability zone and configure the routing to ensure that resources use the NAT gateway in the same availability zone. A NAT gateway supports bursts of up to 10 gigabits per second or 10 Gbps of bandwidth. If you require more than a 10 Gbps burst, you can distribute the workload by splitting your resources into multiple subnets and creating a NAT gateway in each subnet. A NAT gateway requires one elastic IP address. You cannot disassociate an elastic IP address from a NAT gateway after it has been created. If you need to use a different elastic IP address for your NAT gateway, you must create a new NAT gateway with the required address, update your route tables, and then delete the existing NAT gateway if it is no longer required. A NAT gateway supports Transfer Control Protocol, User Datagram Protocol, and the Internet Control Message Protocol. You cannot associate a security group with a NAT gateway. You can only use the security groups for your instances in the private subnets to control the traffic to and from those instances. You can use a network ACL to control the traffic to and from the subnet in which the NAT gateway is located. The network ACL applies to the NAT gateway's traffic. A NAT gateway uses the ports 1024 through 65535. When a NAT gateway is created, it receives an elastic network interface that's automatically assigned a private IP address from the IP address range of your subnet. You can view the NAT gateway's network interface in the Amazon EC2 console.